so well how to do that. I am so proud of you. Now, I'm going to write an equation up here. Say, here's one hydrogen coming together with one oxygen. Well, this is what we're going to form. So how many hydrogens do we need?
I can't see.
Two.
H2O, water.
We need 2 hydrogens to follow that process there, right? So now I'm going to get out some hydrogens and oxygens here, okay? And I'm going to put them on the scale. How many hydrogens do I need?
2.
1, 2. See how that's heavy on that side? Can you see how the scale went that direction?
Yeah.
All right. And how many oxygens do I need?
2.
1. Whoops. 1 oxygen. Why isn't it balanced?
Wait, it
Those
is.
aren't the actual atomic weights.
Wait, it is
Oh, that's not
balanced.
why.
Because they're both way different.
She knows the way.
That's
All right.
the answer.
So, the reason why they're not balanced is because this doesn't say that 1 oxygen weighs the same as 2 hydrogen.
No, it does not.
Alright? Did somebody knock? Okay. If I take this off, is that going to make it balanced?
You don't know.
No, still not balanced. So, 1 oxygen is not, I mean, when we say, and I've already told you this, but I'm making sure that everybody understands. 1 or 2 hydrogens or whatever, when you have a balanced equation like this, it doesn't mean mass, right? It means atoms of things, atoms of things.
Atoms, moles.
So I'm going to translate this. This is a different language. Did you know you guys are learning a different language? Can you translate this into English for me? Some people look at this and say, I don't know what that means. Can you translate this?
2 hydrogens.
2 hydrogens equals water. Plus 1 oxygen equals water. Hydrogen, 2 oxygen.
All right, very good. H2O.
Wait, but I think
So this is
2 hydrogens
translating.
reacting with 1 oxygen.
There's lots of ways to say the thing.
Water.
So this is a different language, and we can translate it that way. Now, I would like to know how many grams of hydrogen do I have to combine with grams of oxygen? And in the end, how many grams of water am I going to get? Okay?
Do we measure them in molecular units?
Okay, so we also said a couple classes ago that 2 moles of hydrogen plus 1 mole of oxygen would yield 1 mole of water, right?
Yeah.
And the mole was our special dozen unit that the chemist invented. Does that make sense? Remember that?
Yeah.
Remember us talking about that? Who else invented a number?
The egg farmers.
The egg farmers, that's right. They invented something called a dozen, right? To help make themselves. Historians invented a score to talk about scores of years, or maybe it wasn't historians, maybe it was, I mean, that's what we think of, we've been saying 7 years ago, maybe it wasn't histories. But anyways, it's associated with old ways of describing old values. Anyway, so how in the world can we identify this? If I want to know, I know that this says, whoops, I know that this says 2 moles of hydrogen.
I'll go get it.
Okay. I know that this says 2 moles of hydrogen, and this says 1 mole of oxygen, and it's going to come together to make 1 mole of water. But how many grams? You can put them in that. How many grams do I need of that hydrogen? How many grams of that oxygen? And how many grams of water am I going to get from that process? Well, to simplify this, to make this easy, chemists started taking all of the elements and putting them into a table. All right? Now, people don't generally memorize the table,
Yeah, that's hard.
okay? But here is the periodic table, and a lot of you have seen this already. Why don't you 3 up front, you 4 up front, share that one. Why don't you 4 right there, share that one. You 3 on the ground can share this one here. Good. Share this one right there. Yeah, that doesn't have the numbers that we're going to need, but that's all right. All right. So, squeeze in here so you can see. Can you guys find hydrogen on this periodic table?
First one.
Yes, it's number 1. It's number 1. Can you find oxygen? What number is it?
8.
8. All right? That 1 and that 8 mean how many positively charged protons, how many protons there are in the nucleus of the atom. You don't have to worry about that for now. But notice that hydrogen has that 1, that number 1 on top. But then there's another number down below. And it has multiple digits as decimal points. Can you read that number? What is that number? Can you read it? 1 point. It's on the bottom of the hydrogen right there.
1.0079.
Good job. 1.0079. Okay? So, yeah. So,
is what
no. The one, because look at oxygen. What's the number down there for oxygen? Can you read that one first for oxygen? Yeah. 115.9994, so it's almost 16. This is a list of all the elements that exist. The top number is the number in order that they come, and the bottom number, that is how many grams you have to weigh out if you want to get a molecular unit. Does that make sense? You can hold on to that one. If you want to get a molecular unit. So how many molecular units of oxygen do I need?
About 16.
No.
About
This-
16.
No.
About what?
Listen carefully to the question. How many molecular units, or how many moles of oxygen do I need for this reaction? 1. That's what this 1 is here, right? I want 1 mole. How many moles of hydrogen do I need? 2. How many moles of water is it going to make? 1. Okay? Now, if I want 1 mole, or 1 molecular unit of oxygen, how many grams of oxygen do I need? Well, that's what the periodic table is for. You go to that number on the bottom of the oxygen, and that tells you how many grams you have to actually weigh out to get 1 unit of oxygen. And what's it say there?
15.9994.
Yeah, so that's pretty much 16 grams. Agreed? 16 grams. So, how many molecular units of hydrogen did I say I needed? 2. I need 2 molecular units of hydrogen. All right, how much does 1 molecular unit of hydrogen weigh?
1.0079.
Yeah, so it's pretty close to 1. But I need 2 of those, correct? So that's going to be how many grams to get 2 molecular units? 2 grams. How many molecular units do I have more of? Hydrogen or oxygen? I have more hydrogen molecular units. But how many more grams? Who has more grams? Hydrogen or oxygen? Oxygen has a lot more grams, huh? That tells us that who weighs more? Hydrogen or oxygen? Oxygen weighs a lot more, right? It takes almost 8 times, or 16 times, no, sorry, 8 times, no, 16. It takes almost 16 times as many grams of oxygen to get 1 molecular unit of oxygen. Okay?
It takes about 8 actually. No, because that's 2.
You can know the ratio by saying how many grams, I'm going to write this information down below here, how many grams of hydrogen are there for every mole of hydrogen?
118.
Okay? And it says there on the hydrogen, this is called a ratio. Have you ever heard these ratios before? Okay, I'm gonna introduce you to some ratios that you might not have heard of. We're gonna play Pictionary. Have you ever played Pictionary? I'm gonna draw something. You're gonna tell me what it is. See who the first one to get it is. Ready? Set? Go.
A 2. Cookie.
Cookie. Who did it? Who said it? Cookie. He got it. It's a cookie. It's a
Okay,
cookie. Now you can see it though. Really good drawing, huh? It's exactly like a cookie. All right. So this is a cookie. This is a cookie. For every cookie, one cookie. How many chocolate chips do I have?
10, 6, 20, 50.
1, 2, 3, 4, 5. I drew 5. See?
Yeah, but you usually have 20.
For this chip, this cookie. 5.
2, 3,
One cookie. There's 5 chips. 5 chocolate chips. Agreed? If I want to say it another way, I can say there's 5 chips for every what? For every one cookie. All right? Everybody see how that works? Here's one more. That's called a ratio. It's showing me how many there are of a certain thing in a given unit. Here's another one. Ready for a Pictionary? Another game of Pictionary?
Yes,
Here we go. Ready? Go.
banana.
Person. Very good. We can make stoichiometric statements about people too. One person. Tell me something that I have 2 of. 2 eyes for every person.
2 feet.
Ears.
All right. Tell me something I have 4 of for every person.
Limbs.
Limbs. Good.
Kidney.
Limbs. Limbs. What's a limb?
1, 2, 3, 4.
Yeah. Things coming off your torso, right? Limbs, legs and arms. Tell me something I have 10 of. per
Fingers.
person.
And toes.
Fingers. One person, 10 fingers. Or I could say 10 toes for every one person. See that? See how that works?
Yeah.
Okay. Here's another one. Ready for this one? Pictionary again. Ready? Set. Go.
Banana. Banana. Car.
Car. Very good. This car,
It looks like a
you know what it's doing?
wheels.
Driving.
It's driving. Is it driving slow or fast?
Fast.
Because it has lines coming out of the back. Right? Driving fast. Which way is it going? This way or this way? It's going that way. How fast is it going? I'm going to call on somebody. Raise your hand. How fast is it going?
Super fast.
Super fast. Give me a number.
100 miles an hour.
Yes.
100.
1,000.
100. 1,000. Now, did you notice that after he said 100, he said something else? What did he say?
Miles per hour.
Miles per hour. Now is that one word? Sometimes we just say miles per hour. Miles per hour. Like it's one word. But what he's saying is that this car is traveling 100 miles for every hour. Miles per hour. That's another ratio. It's another ratio. So here's a question. Here's a question. If I wanted to go 200 miles and I was traveling 100 miles an hour, how many hours would it take me to get there? 2 hours. Okay? So here's how we can solve that. If I want to know how many hours is it going to take me to get, H-O-U-R-S, is it going to take me to get somewhere, I can write an equal sign like this and draw a line and say, well, I'm traveling 100, no, I have to have hours on top. If I'm going 1 hour, how many miles would I travel? 100, because we're going 100 miles per hour. But then I tell the person, I'm wondering how long it's going to take me to travel. How long? 200 miles. If I put the 200 miles up here, I can take the 1 times the 200 divided by the 100. Right? You see that? And that's going to give me how many hours? 2. Now, everybody else says, that's dumb. You just do it like this. No. Right? But I need to teach you something very important later on in chemistry. And so we need to be able to visualize our multiplication and division problems like this. So here is one ratio. It's telling me how many miles per hour I drive. And this is another ratio. See how the miles and the miles, if you take a value like dogs, or any value, any unit, and you divide it by dogs, then they cancel out, right? Time's up?
Yep.
Okay. So, you see miles cancel out here, and I take the value, 200 divided by 100, and then that's going to be 2 hours. All right, you're on your way. You're on your way to understanding how to solve chemistry problems. See you guys.